Okay, welcome to everybody. Welcome, Mr. Matteucci. Welcome also to the supervising team of this PhD ceremony, Professor Gelsomino, Professor Lemaire, and Dr. Maase. And also welcome to the members of the Corona, who I will introduce later on. I hereby open this academic ceremony in which Francesco Matteucci will defend the academic thesis concerning the dissertation Bipolar, biparietal, bidirectional application of radiofrequency in experimental in vitro and in vivo environment. Mr. Matteucci, may I invite you to present a summary of your study and the conclusions of your thesis. The floor is yours.
Dear Prorector, dear members of the Corona, dear family, dear friends, dear audience, thank you for attending my PhD. So in the next 15 minutes, I will shortly introduce the research made at Maastricht University, leading to the final dissertation titled Bipolar, biparietal, bidirectional application of radiofrequency in experimental in vitro in vivo environment. So I would like to start this presentation by highlighting why I choose this picture in this first slide. It has not been chosen by chance or because I'm Italian and Michelangelo is a great card to be played here in this situation, but it reflects the idea behind the whole thesis and the importance of mutual collaboration between cardiologists and electrophysiologists in treating atrial fibrillation. But what is atrial fibrillation? Atrial fibrillation is defined as an arrhythmia with uncoordinated atrial electrical activation and, as a consequence, ineffective atrial contraction and ventricular irregular contraction. Why is so important? First, because it's very common, accounting for alone the 34% overall arrhythmias diagnosed. Second, because it represents an important burden for the healthcare system. 6% of people over 65 years old face it. And with the aging of the population, the estimation of cases are foreseen to be over 80 million only Europe by 2050. And then because atrial fibrillation represents an hazardous condition favoring heart failure, stroke, and mortality episodes. Making a very short description about the most used therapies approach, we can divide the drugs influencing the heart rate, drugs controlling the rhythm, and anticoagulants to prevent the thromboembolism phenomenon, typical of atrial fibrillation. Catheter ablation represents the most common procedure, especially in paroxysmal atrial fibrillation. It comprises a mini-invasive transvenous femoral approach with the introduction of catheters, the reaching of the right atrium, the overcome of the interatrial septum, and the finally attainment of the left atrium. Hereafter, an electric mapping of the surface is performed, and subsequent ablation is based on the prior result. Surgical ablation through a minimally invasive thoracoscopic access, special tools are introduced in the chest of the patient to make a series of lesions based on the most recognized locations of aberrant foci. Different energy sources are used to create maze patterns that redirect electrical signals from the sinus node to the atrioventricular node. Hybrid ablations combines the two precedents described the procedure, the catheter and the surgical ablation. Surgeons and electrophysiologists attack atrial fibrillation from both sides, increasing success rate. Noteworthy, only ultra-specialized centers manage the very complex logistic organizations needed. What are the aims of the thesis? The aims of the thesis are mainly related to three distinctive parts. The first is represented by the findings coming from the first three works, and thus to evaluate the dimension of lesion produced by two different delayed in time hybrid-like procedures, and if a simultaneous application of them from each side of the sample might have produced better results. Then the feasibility of biparietal bipolar radiofrequency in the meaning of delivery energy from both sides, and the comparison with simultaneous and staged hybrid-like mimic procedures. And finally, the assessment of biparietal bipolar setting if compared with a simultaneous uniparietal bipolar application. The second part is much more related to the applicability of biparietal setting in creation of linear lesion under magnetic alignment. And the third part is represented by the evaluation of our in vitro findings in an in vivo environment. Talking about the workflow of the experiments, fresh is slaughtered for human consumption porcine hearts were employed for the experiment, particularly the inferior posterior wall of the left atrium. Then we used a custom-made simulator called Ablabox to recreate the condition outside and inside the left atrium to test different ablation techniques. It has been designed and produced by our group at Maastricht University and validated through published publication in peer-reviewed scientific journal. It comprises two plexiglass chambers with a small opening in the center. One chamber is filled with circulating blood to mimic the internal part of the atrium. The sample being ablated is placed over the little open, being leaked by the blood from one side, endocardium, avoiding the blood coming to empty chamber. Two opposite carts running on low resistance rails hold the pressure sensors on the top and the catheter connected to them. The simulator comprises also an external pump for blood circulation, a thermal pad to keep the physiological temperature, and a magnetic stirrer motor to recreate the turbulent flow typical of the atrial fibrillation. After being ablated, the specimen were sliced. A cryotomer was employed for our purpose, and we set the thickness of the slicing at 100 micrometers. After being sliced, the single layers so produced were laid down on the transparent acetate sheets and dried at room temperature. Once dried, a second sheet was placed to cover all the slices. Furthermore, the sheets containing the slice were scanned to obtain a digital file to be evaluated. Once set up the metric reference, the digital images of the slices were evaluated using morphometric image software to extrapolate the data for further analysis. Well, we started our workflow by evaluating the difference of the lesion from samples ablated with mixed unipolar, bipolar in delayed time, 1 to 4 hours, in hybrid mimic scenario, and the simultaneous application of them. The catheter we used are ordinarily available on the market, as well as the radiofrequency generators. Our findings were that the delay did not influence the dimension of the lesion, and that the simultaneous application from both sides produced quite a bit larger and deeper lesion. Relying on the previous findings, we tested the hypothesis that the simultaneous application in a biparietal setting may have resulted in a broader and deeper lesion. And for this purpose, we built a handmade prototype with the main feature of being employed either in a monopolar or bipolar fashion. The results confirmed that narrower but deeper lesions were achieved using the biparietal settings, and the setup reached 90% of transmurality. The biparietal bipolar setting of our previous experiment seemed to produce good results compared to the unipolar one. Therefore, the third paper compared a biparietal bipolar setting to a simultaneous uniparietal bipolar one. This last one is a very theoretical setting, since to my best knowledge, a clinical application has never been made. Anyway, interestingly, we confirmed the outcomes of biparietal settings, achieving 19% of transmurality, and we accomplished 45% of transmurality in a simultaneous uniparietal bipolar. Linear lesions are an integral part of the surgical ablation procedure. The creation of a reliable linear lesion is difficult to achieve, and it often represents the origin of electrical reconnection. In this part of the work plan, and following our previous findings of the biparietal bipolar fashion, we finally translated them into a reliable and tangible new custom-made prototype, made of 2 identical frames to be placed the first on the epicardial side by the surgeon, and the other one introduced into the left atrium by the electrophysiologist. They are coupled through magnetic elements, and the long flexible electrodes deliver radiofrequency around the pulmonary vein, creating a linear lesion in one stage. And we obtain 100% of transmurality. Finally, the final step of the work plan was to test in vivo our previous finding. Due to the very early stage of the project, we decided to use only 4 animals to make a pilot study. We tested the biparietal bipolar setting with a magnetic coupling system embedded in a handmade catheter in a beating heart, achieving 100% of transmurality in all 4 animals. So what we learned from our experience, that a simultaneous lesion creating produce a broader and deeper lesion, that the placement in a position of the electrodes and the tissue interposed accomplishes transmural lesion on most occasions, and that, including magnetic coupling, we were able to make reliable transmural lesion. So about the future views, despite the early stage to include our results into a clinical environment, we firmly believe that a new generation of tools to face atrial fibrillation is mandatory, because the current tools used in the clinic, despite their continuous attempts of upgrades, they are falling their feasibility. So, relying on the in vitro evidence, lesion reliability might be improved by the biparietal alternative approach, and not working, it could open an interesting approach also for a simultaneous transmural mapping application. Indeed, an accurate electrical mapping within the whole thickness of tissue might give insight into the arrhythmogenic substrate of atrial fibrillation. Going further, an eventual integration of artificial intelligence into the system might sort a very patient-tailored ablation. In conclusion, we didn't find any differences between delay time in hybrid in vitro scenarios. We reached 90% of transmurality in the biparietal approach using a handmade catheter, and that the parietal technique merged with magnetic coupling reached 100% of transmurality and created a linear lesion in one stage. And that the first in vivo experiment, biparietal alignment, reached 100% of transmurality. Thank you for your attention. I give now the word back to the prorector.
Thank you very much for this interesting presentation. We will now start with the opposition. And the first opponent is Professor Vernooy. Professor Vernooy is cardiologist at this university and chair of the assessment committee. Professor Vernooy.
Thank you very much. Dear Mr. Candidate, first of all, of course, I would like to congratulate with this very nice thesis. You did an amazing job, really interesting, especially considering your career track, shall I say. Starting in Italy as a vet, then moving into hospitals, doing a lot of surgical procedures in animals, and then ending up in research, and actually then ending up designing new methods to ablate atrial fibrillation in patients. Of course, it's present in animals as well, but we don't treat them for that. So it's really intriguing how your career path had gone, and a very nice preclinical work you developed. And with that, of course, I would also like to congratulate your promotion team, because, of course, this is always a team effort, but you really finished it very nice. Besides that, of course, I also have to ask some questions. And And with that, I would like to start actually with putting your research into perspective. And that is the treatment of atrial fibrillation. And then I was quite astonished almost that when I read your general discussion on the different treatment of AF was based on 3 different strategies, as you mentioned it. And it's a medical treatment of anticoagulation that's only named as one, and then you go into ablation and minimal invasive thoracoscopic surgery. However, if I put this next to the AF guidelines, that would read really different. Can you maybe comment on your 3 directions, because these strategies are not really in line with the AF guidelines?
Dear highly esteemed opponent, thank you for your question. I'm trying to find the discussion of my book here.
Page 119, yeah.
Yeah, okay. So if I got right, your question is related about my approach, what I wrote about the treatment of atrial fibrillation is based on the 3 different strategies, right? Yes. That is not aligned with the guidelines so proposed. First of all, despite I'm not an electrophysiologist, I'm not a surgeon. So we divided very simple to make a summary about the treatment possible for the atrial fibrillation. I think that my thesis is not well focused on surgery, is not well focused on electrophysiologists, but merge together everything to make a very technical thesis, to make an evaluation of possible approach treatment for atrial fibrillation. So in this scenario, we make this division in the discussion. So about the medical treatment to control the rate and the rhythm of the heart, and the cardiac ablation. So giving the same scenario of my presentation that I just give you. So yeah, this one.
Oh, then I'm glad that we're aligned still, and that probably your thesis one of the methods to develop new tools for rhythm control in our patients with AFib. But of course, we have to do more than just the ablation. That's really nice. Thank you. With that, I would like to continue is actually when I was reading your introduction, and again, I looked at all the different methods that are currently available for epicardial ablation, especially for the surgical ablation. The most performed procedure at this moment is the using of the clamp to perform PVI.
Yeah.
Actually, with this method, and I was thinking about it, looking at your protocols, you're using not so much a biparietal approach, it's more an endo-epi approach, because you really clamp the tissue in between towards each other. So the endocardial sides are next to each other, and from the epicardium on both sides there's a clamp. So that's like a different strategy than the tissue you studied. And I was wondering, did you also consider to use like 2 tissues to put them next to each other and then study the bipolar energy delivered onto this double tissue? Or did you disregard it because you thought that's not the direction maybe we have to go to? I was wondering.
We started from the basic idea that to date the clamp is the most reliable and fast tools to use to make a linear lesion, a reliable linear lesion, especially in open surgery. So when after making a purse string on the left atrium, the jaws of the clamp is introduced into the atrium, and then after closing the jaws, the linear lesions are reliable. So in this scenario, we have a truly biparietal, because we have the electrode that face from one side the endocardial side, and from the other side the epicardial side. So starting from the first evaluation about in the first work that we published about the difference in the late time in a hybrid scenario, then we move on truly biparietal, exploiting these findings that the clamp is the most reliable tools to make this to make linear lesion. So for this reason, we built a handmade catheter able to make a lesion in punctual lesion, because the second paper is related to them, and to make a lesion in uniparietal fashion or biparietal fashion, and making a comparison with the uniparietal bipolar and uniparietal monopolar. And so we found that 90% of transmurality was reached with the biparietal bipolar, instead of no transmurality in the other group.
I understand that, but I was just wondering, because the clamp actually, now also with the new Medtronic lamp, you can actually do, by having like a somewhat more in an angle, you can also obtain a box lesion with this clamp, and you have to avoid, so you have actually bipolar energy in that situation, and you can create a box, and you don't really have to go much invasive, because that comes to my next question. Is it really direction, do you think? What are the future perspectives? That do we have to go endocardially as a surgeon? Because with this method you developed in chapter 4 and 5, actually, then we have to puncture we have to open up the atrium and really have to go from endo and epicardial side to have this best lesion set.
No, our findings are obviously, this is the first step of our research, because, for example, if you have a look to the frame that we developed in chapter 4, in chapter 5, there is no way to translate into a clinical environment, obviously. But our purpose is to test the feasibility of the system, and then shrinking everything. We could obtain a sort of minimal invasive insertion or transcatheter, transfemoral venous insertion of this catheter, reaching the left atrium, and then coupling with the external one from epicardial side, creating a biparietal environment. And then at that stage, releasing the radiofrequency to create the region. This is the first. This is the last step of our research, but we are at the first stage. So now we have to consider the material employed, the technique to shrink everything to make it possible. Because I repeat that the fifth chapter is just a feasible study about how to evaluate and the transmurality in this new approach. Is not new because the clamp is almost the same, but with the magnetic coupling, it could be interesting to through a minimal invasive procedure.
That's interesting. Yeah,
to have the alignment from the internal part of the atrium and the external part of the atrium.
Okay. So then you think the future will be that's extreme hybrid, because then you have a simultaneous epicardial endocardial procedure, while it's now still subsequently being performed. You know, it can be like half an hour, can be weeks or months, but then you really have to go simultaneously. So there's a future for the cardiologist to work more closely with the surgeon in the future. With that, I thank you very much for your answers. I like them very much, and I give the word back to the prorector.
Thank you very much. Then the opposition will be continued by Professor Bisleri. He's a cardiac surgeon from the University of Toronto. Welcome, Dr. Bisleri. Glad you could be here. The floor is yours.
Thank you very much, Madame Prorector, and thanks for the committee for having me here. First of all, let me congratulate the candidate and his promoting team for the really outstanding and provocative work in trying to identify new solutions. I think that the expansion of minimal invasive techniques is obviously been very vivid over the last 10 years. And I think that the different techniques that we've been exploring, different technologies that we've been exploring, have not been able to address some of the limitations, which include the possibility, even with a device like a bipolar clamp, to be fully transmural in a systematic fashion. And having the chance to somehow merge the two words, I think it's a very, very interesting option. So again, my first question is going to be very technical, related to the prototype. Of course, like any technological advancement, the first few iterations may be still not the best option compared to the potential clinical application. But my understanding from your dissertation, and especially the figure 1 on chapter 5, when I see the image of the prototype, and the idea, of course, is, which I honestly find very important, the possibility to reproduce a continuous box lesion set, which is the ideal kind of cornerstone of the ablation that would be aimed at. You are aiming to do so by using a design derived from, my understanding, a bipolar clamp, which is something that can maybe not necessarily match the anatomy or the different anatomies that may be found in patients, especially when you're trying to do both an epicardial and an endocardial approach. So this is my first question to you. How do you think the prototype you've been working on can potentially be realistically applicable in the human anatomy, not simply when tested on the ABLA box, considering the different variations?
So, dear highly esteemed opponent, thank you very much for your kind question, and for your kind words. Yes, I'm having a look to this figure, and obviously, we are aware that we have a lot of species differences between the number of the pulmonary vein. For example, in pigs, we have 2 pulmonary veins. Using the dogs, we have from 5 to 10 pulmonary veins, and the human, we can find 3 to 5 pulmonary veins. So there is a big heterogeneity, and also between the patients, the distance, for example, from the right to left venous pulmonary veins compart could be very, very different. So your question is a very insight, and to answer to your question, obviously this is the first version of our prototype. And you are right, because it was derived from an electrical scheme from a clamp. And for this reason, this particular frame is limited in length, because we tried to extend the length of the electrode, but unfortunately the generator we used was so closed in the setting, in the meaning that the algorithm inside the generator changing the output of voltage and the impedance depending on which kind of device was plugged in that moment. So we tried to build a longer electrode, but it doesn't work because maybe the algorithm inside the generator stopped the process. And so this is why we are actually stuck to this linear dimension. But anyway, going further and making studies, and most of all, having a company behind, having some investors, and having generators more open in the settings, we could study better how to make this new prototype more flexible and adapting to various different scenarios. Obviously, going to the clinic is too early at this stage, as I already said. And but in future, I'm positive and to think that the right way to move forward.
Thank you. I have another technical question. If I understand correctly, the way the magnets are working is that right now they're not electromagnetic activated, but they work all the time, which is clearly something that should be investigated in the idea of merging the two devices. Otherwise, that would not allow a proper alignment. So I'm wondering, what are your thoughts or consideration regarding this aspect?
Yes, the magnet. You are right. The magnet employed in this frame are a fixed magnet, and so we are planning to use the electromagnet, because electromagnet have the feature that can be activated and deactivated, changing obviously also the power. And so, for example, when we put this frame into the Abla box from one side and the other side, it was very tricky to align, because having a fixed magnet, sometimes we fail to make a perfect alignment, because the alignment was wrong, because the activity of the magnet is continuous. So swapping to electromagnet, this could be very, very interesting, because the alignment could be done by setting the activity of the magnet on the particular edge, particular side of the frame, and so allowing a perfect alignment. Then I will stress also, for me, an important fact that since we know that the thickness of the atrial tissue is different also from healthy left atrial tissue, from atrial fibrillation patients, that is thinner. And using an electromagnet, it could be very interesting to apply the same contact force. Even the thickness of the atrium is different, because we could apply, maybe under computer control, we could apply much contact force on thicker tissue, and lower contact force on thinner tissue, to have a constant and homogeneous contact force all along the frame.
Thank you. And I hope that maybe for the sake of time, I'll just ask you a very quick last question, is regarding your perception. This is, as I said before, a very interesting option to improve the efficacy and the transmolarity of lesions. Given the growth of novel options, for example, electroporation, which appears to be offering irreversible destruction of cardiac tissue. How do you think this approach could represent a similar, different, and alternative? What's your feeling?
Thank you.
Sorry, maybe you can try to give a short answer.
Yes.
Okay, electroporation is very attractive. Is very attractive technique, and I think that our device is very adaptive for this technique, because it creates an electric field all around the inner area, and the electroporation has a very interesting feature. For example, the lesion that he made is not based on a thermal effect, and this is very important, because the thermal effect is one of the main drawbacks, for example, catheter ablation, and then it needed also the contact. Okay, so I think it's very promising. Unfortunately, the power that needed to provoke the irreversible electroporation is very high, because it's still 200 joule. It's very high. But in this biparietal setting, for example, the simultaneous application of less power, it could be very good for the patient, because of the overlapping of the two electric fields. Sorry. So I think it's a very, very important application for the future.
Thank you very much for your answer. The next opponent is Professor Moroni. Professor Moroni is professor in biofabrication for regenerative medicine of this university. Professor Moroni.
Thank you, Madam Prorector. Dear candidate, I also would like to congratulate you and your supervisory team for a very interesting piece of work that I have had the pleasure to read and to actually learn from you in respect of the different in vitro prototypes that you have developed and their possible use for atrial fibrillation treatment. I'm not going to ask you questions over the specific topics and the specific work that you have provided in the different experimental chapters, as I've seen also that with pleasure that this has been nicely published also in peer-reviewed journals. But I would like to take you a little bit of a journey on a journey with me on the future. So if if I would be a philanthropist and I would have €1 million to invest in you, what actually would it be the next steps that you would implement to further bring this technology forward?
Okay, dear highly esteemed opponent, thank you for your question and for your kind words. Maybe for my dreams, 1 million is not enough for developing the catheter, because me and my group in this moment, we are trying to extend this concept and including also artificial intelligence, for example, for a very, very patient-tailored ablation, and to study exactly the pathway, the electric pathways that are responsible of atrial fibrillation, obviously. And with the biparietal, we could also provide a simultaneous mapping application, electromapping application, because I think that this is very important, because actually the electrical mapping is made only or endocardia or for endocardia or by epicardia, with the problem epicardia that the presence of the fat. But I think there is something complete, because it's if you have a patient that has, for example, most endocardial circuits, and you make your evaluation on endocardia, you can find exactly the pathways, and everything is okay. But if you find a patient that's from endocardia, I'm talking about, that has most of the circuits located on the epicardial side, then you are not able to find everything, because if from endocardial you can see a certain scenario, but it doesn't reflect the effective situation of the patient, because most of the electric pathways are located on the epicardial side.
And is there in that concept, is there also something to say on the transmural?
Yes, I think because I'm not an electrophysiologist, but I think I told with them obviously, and making a simultaneous mapping transmural, it could be a very, very interesting to find the arrhythmogenic inside the thickness of the tissue.
Thickness of the tissue, yeah. Okay, I mean, I'm pretty sure that you can talk for pretty much the rest of the time that I have available on what can be done in the future, but let me try to dialogue a little bit with you. If I understand correctly, and please, man, here, teach me, because you are here the master. With this technology, you create an ablation, right? So you basically creating a damage, if you wish,
yeah.
a localized and and on purpose damage to the atrial wall in order to reconnect some of the electrical connections at the cardiac muscle side. Am I correct?
Yes.
Okay, so I that I work with tissue regeneration. So whenever I hear about a damage, I always start to think about how we can actually repair damage. So in that respect, do you think, what do you think actually, if you would give me an advice, what kind of biomaterial should I provide to our fellow colleagues here, clinicians, to actually maybe combine with the ablation setup that you have been studying?
So, for example, I think that the material, the polycollagen material, I think it's very suitable for this device. For example, for this kind of device made of polyethylene oxide terephthalate, for example, and.
Okay, yeah, you're going already in quite some specifics, which is great. I mean, but I mean, collagen, I think would be I guess, I can relate to that, right? Because I guess in the cardiac muscle you would have quite a bit of collagen. Would you, for example, want to have electrically conductive biomaterials to help in restoring this electrical activity, or better not to mess with the electrical signals of the heart?
No, it's supporting the electric material, conductive. Yeah.
So a collagen that is electrically conductive could be an interesting solution. Do you also consider what happens with the ablation? Are you burning away the tissue, and do you expect to have damage, for example, at the cell level? Should I also worry about cells, or would just a quote unquote simple material be suitable for a possible repairing need?
So during the ablation, basically the radiofrequency creates a heating injury and subsequent coagulative necrosis. Mm-hmm. So that's it.
Okay. So yeah, in other words, you would see a need for replacing a necrotic tissue with a living tissue, or do you think that the heart itself will be able to do that?
It depends on the amount of lesion that we are planning to do.
Okay. All right. I am actually satisfied with the replies of the candidate, Madam Prorector, so I will leave you back the word. Thank you.
Thank you very much for your contribution. The opposition will now be continued by Professor Pisson. Professor Pisson is Professor of Clinical Electrophysiology at Ziekenhuis Oost-Limburg, Genk in Belgium. Professor Pisson, the floor is yours.
Thank you, Madam Prorector. Dear candidate, first of all, I would like to congratulate you and your supervising team for this excellent work. And I would like to ask you a few questions, more from a, let's say, clinical point of view, if you don't mind. First of all, in chapter 2, where you describe actually looking at the sequence of the hybrid procedure, it doesn't make any difference doing it in a single procedure or sequential approach. However, you were using a pen-like device to look at the lesions. Do you think using another device like the Medtronic clamp would make a difference? And I'm asking you that questions because I'm seeing these patients a lot in the cath lab. And after using the Medtronic clamp, for example, the box is almost always complete. So do you think that would make a difference using another type of device?
Dear highly estimated opponent, thank you very much for your question and for your kind words. In chapter number 2, we make an evaluation between one stage in a hybrid-like scenario and and simultaneous, that it's a very novelty, and the delayed time. So for my best knowledge, the pen is almost used in creating linear lesion in surgical ablation. So we decided during the hybrid scenario. So we decided to use a bipolar, a uniparietal bipolar, to prove that, not to prove, that to use this one, and to on the other side, using the uniparietal monopolar radiofrequency. So the clamp, it was not taken in consideration, because the clamp, we used the scheme of the frame of the clamp in the 5th chapter, using and making the frame, the long frame for surrounding the pulmonary vein. So I agree with you that the clamp is good in obtaining some results, some good result. But for this chapter, this work, we use the epicardial, because it wanted to demonstrate that the placement of the electrode on the same site produce a very tiny linear, a very tiny and not so deep lesion, because of the presence of the blood inside the left heart, acting as a heat sink. But anyway, we want in the future, we want to extend our study, obviously including also different type of clamps to understand better how to move in the future.
Okay. I have another question regarding the use of specific materials in the prototype you described. Because what strikes me is that for the ablation trails, you use copper.
Yes.
And copper is a material, as far as I know, that's not used in endocardial catheters. So why do you use copper? Can you convince me, the industry, to make copper-containing catheters?
No, you're right. Copper is very toxic. It's very toxic. But at the time when we built the prototype, it was the only material very, very easy to find, very cheap, because the other materials that are commonly used in radio frequency, to deliver a radio frequency, it's gold or platinum. And most of the time, in this case, we use a braid. So this is why we use the copper, because to the best of my knowledge, and it was very easy to find on the market, a braid to be flexible. This is why, the only reason why we choose copper. Because
do you think using something else like gold or platinum would make a difference on the results, or?
I think that gold is better than copper as a conductor. So I guess so. But again, we need to move forward and to make studies to explain this difference.
Okay. Continue on that. So using the prototype almost guarantees transmurality. You agree? It's almost 100%. Keeping that in mind, what would be, in your view, the ideal lesion set to start with? So because the lesion set, which lesion set would you advocate for a surgeon to make using your device, knowing you will have 100% transmurality?
Yeah. Me and with my group, my promoters, we are developing, for example, a new catheter based on this idea of biparietal. It's a sort of a snake that surrounds the pulmonary vein. And we have a catheter on epicardial side and the other on the endocardial side. And they close together, they attract together by magnetic coupling. And we have also a third catheter rolling from the one part of the catheter that we call the tongue. It's to make a lesion in the area comprised between the right and left pulmonary veins compartus. Okay, so at the end of the process, we should have a box lesion and a sort of the tongue that comprises also electrodes on its surface to create ablation in the area comprised between the right and the left pulmonary vein compartus.
Is your device usable to create lesions on the right atrium? Can you isolate the cava superior, or can you ablate the cavo-tricuspid isthmus?
Yes, it's possible. Not that kind of catheter, but is an iteration of this catheter. But the idea to combine by biparietal is still good also for caval vein, for example.
Okay.
So yeah.
And I have, if I may, have a short last question. In your last chapter, you suggest that this catheter can be used also for other arrhythmias. And I suppose you suggest we could treat ventricular arrhythmias using this device. How would you see that? Because using those devices is for creating linear lesions, right? And actually, we don't need that often linear lesions to treat VT or ventricular tachycardia or VF. So how do you see that? Be a short answer if possible.
Yeah, it depends on the shape of the catheter that we decided to apply, basically, because it's more tricky to treat the ventricular arrhythmia, but it depends on the shape. So when we establish a well contact with our biparietal technique, changing the shape, I think, also the dimension of the catheter, it could be feasible to treat also the ventricular arrhythmia.
Okay, thank you very much for your answers.
Thank you. The opposition will be continued by Professor Kierkia. He is from University Hospital Brussels, also in Belgium. Professor Kierkia.
Thank you, dear Prorector. I would like to congratulate the candidate for this wonderful work. Congratulations. There have been many technical questions. I think I will go more on a electro-philosophical, futuristic question. And I strongly believe that I'm not even sure transmurality is actually the way to go around the PVs. For sure, permanency of PV isolation would be better defined. Today, with the advent of pulse field ablation and more knowledge on cryoballoon ablation, which is what we perform a lot in Brussels, we have permanencies of PVI probably at redo procedures until 90 to 95%. Now, reaching 100% is a lot. This is why we tend to give more to our fantastic surgeon, which is Professor Lamer, the toughest cases, which are, permanent or long-standing persistent AF. So I strongly believe that, with all due respect, and maybe this is a bit, on the negative side, PVI will be treated less invasively and more by DPs in the future, more and more, considering also the speed of the procedures. My question to you is, first of all, you actually say it yourself, because in point number 7, you cite Jimmy Cox. So I would like you to comment philosophically on that point, please, candidate. Okay.
Highly esteemed opponent, thank you very much for your question and for your kind. Yeah, Jimmy Cox was the pioneer of the surgical ablation, and he started from a cut and sew technique. It's very, very pioneeristic, let me say, because I think it's very dangerous. And after the many attempts and many failed, let me say, the last version of Cox-Mates number 4 is still today to the gold standard, and for about 3 of AEF. And in his editorial in 2018 in the European Journal of Cardiothoracic Surgery, it make a bright description of about the pulmonary vein, about the paroxysmal atrial fibrillation, and so that to date it was efficacy. The pulmonary, the catheter ablation was efficacy in the treatment of pulmonary vein, but he focused also why in long-standing persistent we struggle a lot to obtain good results, and he pointed the light on the tools. Because the tools are limited, are not very focused, are not very adapted, for example, in hybrid scenario, because they are really mutuated from surgical ablation and catheter ablation, but we have no very, very specific tools for to use in a hybrid scenario. And so he foreseen that the surgical ablation on pump, the coxswain is on pump, and hybrid is only a treatment why we are waiting a new generation of tools, more specific. And I would say also that we have some good procedure, good news procedure. For example, the high power short duration. I think that it's not important also the new tools, but even how to manage the energy, how to deliver the energy. So I think in this scenario, I think the high power short duration, I think it's very important. I think it's very promising, because if we consider how the radiofrequency is delivered in the tissue, we know that it's composed by two things: the resistive heating and a conductive heating. So in a standard ablation, the resistive heating is only limited on the few rims of the tissue, and the rest is made by conductive. Is the so-called thermal legacy phenomenon. In fact, if you know that better than me, obviously, that the shape, the typical shape is a drop, okay? But this conductive heating is very dangerous, because we are not under control or how to spread. And with this new technique, this new feature, it's the balance is different, because it's more resistive and less conductive energy.
Yeah, okay, you talk about radio frequency, we all agree. I think we'll more and more step away from thermal ablation. If PFA holds its hopes, I think, I mean, well, in our hands, it takes 15 minutes to do a PVI. So I think I would step away from PVI in terms of hybrid ablation. In terms of surgical ablation, would never get a PVI for surgically, personally. But what is very interesting that you said is that you can map endoepicardially, and this, I think, is the key, because we're always talking about lesion sets, and this is all very good. But I think, and not only me, but anybody has obviously, being an EP, realizing that long-standing persistence, or also persistence themselves, have very different phenomena electrophysiologically. So I'm not sure that a determined lesion set will cure most of them, but more understanding what's the underlying disease in any given patient. We have a very new mapping system, non-contact mapping systems such as Acutus, which are giving decent results, or at least telling us where things are supposed to be happening. So very interesting from your point of view, the fact that you can do endoepicardiac mapping for more advanced stages of the disease. Completely agree with you. That's an up figure. One last thing, I wanted to bring a bit of, happiness also into this sad period. Could you please tell me point 10? I like it. I started biking and I loved your point 10. So why did you write this?
Okay. Yeah, this is a very sympathetic sentence that I found on the internet, and it reflects about my biggest passion as the motorbike, and as passionate about the motor.
Hora est.
Okay, pity. You will talk about it later.
Okay.
Yeah, you can give a very short answer. If
Yeah. Yeah, basically,
Sure.
yeah. I read in the past a famous book, the art, the Zen and the art of maintenance of motorbike by Robert Pirzig, and he affirmed that it's completely different driving a car and driving a bike, because if you, for example, if you're driving a car going from point A to point B, it just, you have to move in the shortest time, because and you are not in the trip. But in the bike, driving in the bike is completely different, because it's the trip from point A to B that make the difference. You enjoy the trip. You are feeling everything, the wind, the tarmac running beneath your feet, and that's, it's very cool. I think that is the closest way to closest experience to fly, in my opinion. But I'm very, very passionate about the motorbike, so this is my, yeah, this is my feeling.
Thank you.
Thank you very much. Mr. Matteucci, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. And I request you to wait the results of our deliberations and our return in this room. Oh, I'm still muted. No, I'm muted. Mr. Francesco Matteucci, the degree committee here present online has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Gelsomino is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor now to take the floor.
Dear Mr. Candidate.
Please adjust your camera, we don't see you.
Dear Mr. Candidate, do you promise to work in accordance with the principle of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present online, I hereby confer upon you, Francesco Matteucci, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, you will soon receive the degree certificate signed by the rector, the secretary, and the supervisor, affixed with the official seal of the university. Now the certificate is shown by the beadle. What Ms. Prorector. Madame Prorector.
Yes. I'll give you the floor for the laudation.
Thank you very much, Madame Prorector. Dear Dr. Matteucci, dear Francesco, the big day has finally arrived, and there are so many things I wish to tell you today. However, since I started writing the speech, I've realized that a whole book could not have included even a small part of what we have shared together during these years. Preparing this laudatio, my thoughts were running through my mind so fast that I was not able to fix the 100,000 words that came to my brain and that I would have said today. Nonetheless, I do hope that from this speech, the message came across of how proud of you I am today and how much delighted I am for this achievement you definitely deserve. I will start from the beginning, when we met each other 15 years ago and we started working in Careggi. Since then, how much work together, how many whole nights spent in the operating room, always side by side, joined by our shared love for surgery and research. And now you are standing here. However, apart from the motivated, hardworking, creative, and full dedicated researcher, those days I had the luckiness to meet a true great friend, always there in good and bad times. Trustworthy, loyal, always patient with such a grouchy man. Nonetheless, it would be an understatement to highlight under these circumstances your friendship, though valuable. without bringing to light the enormous work that turned into the researcher you have become, without bringing to light how you became a world-renowned researcher, I would say. Atrial fibrillation fascinated you from the very beginning of your adventure, and the more you enriched your knowledge on this topic, the more you showed a very clear and strong vision on innovative technique that will change the way we deal with this challenging disease. However, if I ever be asked what your main distinctive skill is, I would emphasize your ability to move forward no matter what. When the hurdle is set too high, you never give up. You always see it as a challenge and not as an obstacle. Not to mention the congratulations I have unworthily received every time you have wonderfully handled the experiments in the lab room. During these years, I've seen you enormously improve as a researcher to acquire an increasingly self-awareness and grow within the group, bringing a very interesting multidisciplinary vision on how atrial fibrillation treatment might look like in the following years. It was a great pleasure to be your supervisor all these years, but I would also like to emphasize the role of Professor Lamer, who has been for you of great support during this adventure. And I would like also to highlight the precious role of Dr. Bart Maastricht to move forward within clinics. Your passion, your mild character, your brilliant intelligence has been an important glue for all the members of the group. Your shyness and your modesty have sometimes brought you believe that this achievement would never been possible. But I had no doubt from the very beginning, and I perfectly knew that this goal was fully within your possibility. Today, while remaining an humble man, you may have a rising awareness of your great value. But Francesco, please, be more confident, more self-confident, but stay what you are. Dear Francesco, you can be proud of yourself. You have reached a great milestones, and I think it will take some time to realize what you have achieved. I am happy that I am given the chance to be the first to congratulate you with obtaining this PhD title. So congratulations. Dear Alfredo, you must be proud of your dad and consider him as a model to be followed, as a role model. And dear Giovanna, I will know how much time research takes away time from family and makes it difficult to maintain a consistent social life. For this, I want to thank you for strongly supporting your husband, who today has given you such an enormous gratification. Finally, I want to congratulate Francesco. I want to congratulate your parents, your dad, your mom, your sister. I am only sorry that the COVID did not allow us to celebrate this very important day together, but I think we will do it soon. Dear Francesco, I wish you for the future the best you deserve, and I wish you success in your future career. I hope that this be only the first of many goals that we achieve together, and that journey started many years ago can continue unaware of the obstacle, and I be the witness of many your future achievements. Congratulations and bravo, Francesco.
Thank you. Dear Dr. Matteucci, also on behalf of the Board of Deans of Maastricht University, I congratulate you with the honor you have acquired. It's a pity it had to be online, due to the COVID situation, but I hope you're able to celebrate in Italy with your family and possibly also friends. I don't know how the situation in Italy is and whether you can meet with more than 4 people like we are allowed to do here. But anyway, have a good time for the rest of the day. And of course, we hope to see you in Maastricht again. That's it for all for now. I'd like to thank all the Corona members for their time and effort in being at this ceremony. And I now declare this ceremony to be ended.